Assume the detection of a pulse signal of non waveform is immersed in additive white noise AWN. The device for optimal detection of such a pulse uses a LTI filter known as the matched filter. Signal G of t, now white noise X of t, LTI filter of impulse response H of t, sample at the time t is equal to t. Consider the receiver model shown in the figure involving LTI filter of impulse response H of t. Filter input X of t consists of pulse signal G of t and is connected by the adaptive channel noise W of t. X of t is equal to G of t plus W of t, 0 less than or equal to t less than or equal to t. Pulse signal G of t represents the binary 1 or 0. T observation interval W of t is a sample function of white noise process of the 0 mean, and power spectral density is n0 by 2. Source of uncertainty W of t. Receiver has to detect the pulse signal in an optimum manner. Detect G of t from receiver signal X of t using a linear filter. The resulting output Y of t is equal to G0 of t plus N of t. G0 t is the signal component of X of t. N of t is the noise component of X of t. N of t is the input signal to filter. Then Y of t is the output signal to filter. G0 of t is equal greater than N of t, maximizing the peak pulse SNR. Eta is equal to G0 t squared by E of n squared t. Instantaneous power is in the output signal G0 t square. Expectation are in average output noise power E of n square of t. G of t, F of t, G of and H of S frequency response of the filter. Fourier transfer of the output signal G of t, G of F, G0 of F is equal to G of t, H of t, G0 of F is equal to G of F, H of F. Time domain and convolution is Z frequency domain multiplication. G of t is equal to inverse Fourier transfer of G0 of F. G is equal to G of F, H of F. G0 of t is equal to integral minus infinity to infinity G0 F e raised to j 2 pi f t df. G0 t is equal to minus infinity to plus infinity G of F, H of F e raised to j 2 pi f t df. Filtered output of the sample at a time t is equal to t given by G0 of t square is equal to mod integral minus infinity to infinity G of F, H of S e raised to j 2 pi f t df all square. Effect or the filter output due to noise Wt acting along power spectral density of the output noise N of t versus power spectral density of the input noise W of t times square magnitude response of the filter.